Hello, this is CUDAN Open Lab seminar on December 3, 2024. It's our greatest pleasure to have Miriah Meyer from the University of Linköping speaking about troubling visualization. This is an utmost pleasure, I have to say, because Miriah Meyer is one of the coolest people in visualization. There is like whenever I teach visualization, which I do since 2013, I try to get people into, for example, workflow design, and there's a number of things that come up. So there's basic pipelines like Ben Fry's, then every data science, every machine learning textbook has a workflow pipeline with feedback loops. And I think the most feedback loops actually has Miriah Meyer's model, which is the one every student has to learn. And so that is sort of something that is really cool. And also, Miriah Meyer worked for, like, you were at the University of Utah, but you worked with the Broad Institute. So you helped a lot of biologists seeing their data in ways that they didn't see the way before. And that comes with a lot of critique with established conventions, while at the same time also this allows you to have the freedom to come up with really new paradigms. And that is sort of something that is utterly cool. There's another thing which I find utterly cool. You made it out of Utah, just like I made it out of Texas, and we both ended up in Northern Europe, which is also weird and cool. So the stage is yours, Miriah.
Thank you so much. And yeah, thanks for this invitation. Looking at the, back at some of your YouTube videos and stuff, it's a very interesting group of speakers you've had. So I'm really tickled that I got asked to be part of this. So I'm excited today to share a talk with you all that admittedly is sort of a work in progress. And it's kind of a talk that's laying out the sort of vision that I'm hoping to kind of pursue over the next, I don't know, chunk of my academic career, and has very much been rooted in opportunities here in Sweden since I moved here about 3 years ago. Previously, I was at the University of Utah for 10 years. And as Max said, like historically, my research has been very much grounded in designing visualizations, co-designing visualizations with people in the world that have data. How do we do that collaborative work? How do we design tools? And what do we learn from that? And that's been sort of the trajectory of my work. But over the last few years, I've been digging more deeply into theoretical foundations of the field of visualization and of a lot of fields that kind of orbit around it, to really try to think about where we are as a community, how to handle some of the tensions I see arising, and what it might mean for where we go in the future. And so I'm going to lay out some of that in this talk. But again, because these are somewhat newish ideas, I'm super interested to hear how this lands with you all. And I'd love to get your thoughts and feedback and critiques on the ideas I present. So with that, I guess I will jump in. So let's see. Okay, look at my first slide. It is a model diagram with feedback loops. So I like to start here because this is something called the reference model that still gets taught in many intro to visualization courses today. It is a model that was published back in the late 90s. And this model was meant to define, like, what is this thing called data visualization? And this time in the late 90s was back when like computing power was just really starting to take off in the hands of everyone. All of a sudden, we were starting to get bigger data sets in health, in medicine, in business, and things like that. And people were like, well, what are we going to do with this? And it was really kind of the emergence of interactive visualization at that time. And so when this model was published, it was really published as a way to try to say, well, what is this thing of visualization? How does it work? What are the things we care about? And, it really sort of lays out this notion that, as viz people, we sort of start with this sort of raw data that we sort of ingest into our computational programs and software. We, process it into tables and different kinds of representations really that we can work with. From those representations, we can map that onto different kinds of visual structures that give different kinds of impressions of data and the interesting things in it. Those structures get rendered onto a screen that we can then interact with. And at the end, someone's sort of looking at all this to do some task and to have some insight. And these things are interactive, so we can go back and change the views and change the mappings and so on as someone is exploring their data. And, since this model was published, we've added things like models. We don't just care about data, but we also care about models and algorithms and things like that. And it's not just about a person doing a task, it's about getting insight, about creating new knowledge, and so on. But at the core, this pipeline really represents what I think are the major matters of concern of the Viz community. So why is this interesting? Well, I think it's interesting because I think it's it's no longer working to explain all the things that we as Viz researchers care about anymore. So I'll give you some examples of some interesting tensions I've seen come up. So this is a paper from 2019. It was a really interesting interview study that was conducted by some researchers from Bucknell University, where they went into areas, rural areas in the US, and printed out visualizations of different sorts, of different kinds of data sets, to get people's impressions and to see which ones they thought were useful or not, or high quality or not. And what their findings pointed to was the ways in which people's personal relationship to the topic of the data, like some of these topics were things about drug overdoses or gun violence and things like that. So people's personal relationship to these topics that data was covering, and also their own backgrounds and what they found aesthetically pleasing, very much impacted the kinds of responses that they were giving in these interviews. And so the main takeaway from this was really that sort of data and people's interactions with the visualization is highly, highly personal and situated. Another paper that came out looking at some things going on during the COVID pandemic. This was a really interesting study by folks at MIT, where they studied the use of visualizations by people in the anti-science, anti-vaccination communities. And they were really interested in just sort of trying to understand, how were people in these kind of anti-science communities, how were they using visualizations? What kinds of visualizations? Were they different than how public health messaging was going on? And what they found was basically that these communities were using the same kind of standard charts, and in many cases, even the same data sets as public health officials, only to communicate vastly different messages. And another fairly recent paper was a really nice theoretical and historical look into how we have visualized the human body over many centuries. And what this paper really brings forward is how the ways in which the human body has been represented, all the way to sort of our modern day today, is very much situated inside of the norms of science, of culture, and of society, and that those things are impact the ways that we visualize the data and anatomy of the human body, and sort of bringing to question the things that we think today are objective and neutral, and how much are they really? So, okay, great. So a bunch of interesting things. And I'm interested in asking the question, well, what's going on in works like this? And what I want to propose is that it's time to rethink this the standard way of thinking about visualization. And again, the standard way in a simplified form here is basically how we think about the data as raw, that the data coming into our work and pipelines is this, we bracket away all the things that came before. We also think about visualizations, and I'd say to an extension, this is also the same case for models like ML and AI models. We think about these things as transparent windows onto the data. So when we design a visualization, it's about giving this unbiased view to the readers of that visualization. And then we also tend to think about people in terms of their perception and their cognition. So a lot of people in visualization have been doing a lot of user studies to understand how do people read visualizations, which kinds of visualizations are most quote unquote efficient and good. But we do this by solely focusing on perception and cognition. And what I'm interested in doing is troubling this in a couple of ways. And the first one is to start thinking about data as this produced object. We think about data not so much as a truth in the world, but we instead think of it as something that is produced through systems of power and privilege, of history, of convention, of availability, of technologies. Our notion of what data is can become quite different, and I think that has implications for what is it we're even designing for as people. And then I think also it's time to move beyond thinking about visualizations as these windows and to instead acknowledge that they are non-neutral, to acknowledge that they are subjective lenses, that the visualizations I design give people access to some knowledge at the exclusion of others. How does that change the ways that we think about our tools and how we assess them? And then finally, thinking about people as very real people with hopes and dreams and histories and biases and joys, and to acknowledge the ways in which someone's interaction with a visualization goes way beyond just what their cones and cells in their retina are signaling. So it's time to think about people more holistically in this sort of embodied notion of visualization. Okay, so that's like a lot of words, but my notion of troubling visualization is about how can we rethink these core concerns in the Viz community from new and different perspectives. And so that's, oops, okay, well, I went through that transition. Anyway, that's what I'm doing in my new group here at Linköping University. I'm working with a number of postdocs and students. And along with a few other faculty members, we've created this new unit that we call Visualization and Interaction Design. And the sort of thread that threads our research together is really this idea of approaching research and design into research and design of different kinds of materials and modalities and interfaces for thinking about data, approaching it from a designerly perspective. And so in that regard, it's about how we can use the process of design to learn about what it is, to learn about new things in the world, and to also think of these designs as sort of speculations and new potential futures, as opposed to just, these tools that are a static thing that we release into the world. Okay, so what I want to do in the rest of the talk is with that kind of like very high level, perhaps slightly hand wavy sort of framing, I'm going to give you just a couple of examples of projects to try to contextualize, what does this mean in practice? Like, what does this perspective mean for doing visualization research? And I want to start with a project that we call Data Hunches. And Data Hunches is actually rooted in some work that I got to do with my PhD student, Nina McCurdy, back in like 2015, 2016. And this project was rooted in a collaboration with public health experts who were studying or who were trying to counteract the spread of the Zika virus in Latin America. And I don't know if you guys remember, this was quite some time ago, but Zika was spreading, during these years quite in a quite scary way, not so much because Zika itself to the infected person is that dangerous, but the problem was when women who were pregnant were infected with Zika, it was leading to a lot of problems for the developing fetus and leading to things like microcephaly in babies. So there was a lot of international aid organizations that were looking at how do we sort of understand the spread of the virus and then use international aid organizations to try to combat it. So we were working with a group in Washington, D.C. They had a lot of data. They were struggling to make sense of it, and they were really excited to work with us to try to come up with some new visualizations. So Nina went and spent 6 months in DC doing a field study with this group. And during that time, she did all the things that we do in collaborative work. She interviewed people, she observed them in their work practices, she ran workshops, she did some iterative design work, and ultimately ended up with a tool that looked like this by the end of that field study. And this tool really takes like sort of best practices for looking at geospatial and temporal data in an interactive way. So before she left, she did a bunch of feedback sessions with a variety of stakeholders. And everyone that she showed this tool to said, this is a really, really great tool for looking at this data. But then we tried to get our immediate collaborators to use this tool in their daily work, and they were really hesitant. And we were like, but everyone's saying this is a great tool. Like, why isn't this useful? And so as we dug into this, we started to realize that even though the tool was a great representation of the data was not a great representation of what these experts knew to be true about the spread of the virus on the ground. And so, for example, this was coming up in conversations around visualizations like this one, where in this chloropleth, we see Brazil in a dark red, indicating a relatively high percentage of cases, compared to Colombia, that's in a lighter red, and thus a lower percentage. And when we showed this to one of our collaborators, she was like, well, Brazil reports all cases, suspected or not, as cases, whereas Colombia only reports after a thorough lab investigation. And so the implication of this collaborator's response was that different countries and different regions are reporting and assessing and collecting their data in different ways and under different norms. And that was leading to data sets that are misleading and visualizations like this that could give people perhaps even the wrong picture of what's going on. So we started to notice this all over the place. We heard people say things like, the union in region X goes on strike often and doesn't report Zika data. Or country Y recently overhauled its surveillance system, leading to a sudden increase in detected cases. And I should say that the data that this group was using was World Health Organization data, WHO data. So it's sort of like the gold standard of what these organizations use. So we got interested in this, and we decided to kind of pivot in our research focus and instead focus on this notion of the discrepancies in this data. And we developed this idea that we called implicit error, which is error that's inherent to data that's not explicitly recorded, but is known by experts who work with the data. And so Nina designed an annotation mechanism for our collaborators to externalize what they knew and about these problems with the data, and to then have that be back in the tool for them to share amongst their group. So, okay, that was nice. But when we got time when she gave the presentation of this work at our large Viz conference, we still had a lot of uncertainty in our own minds about what would be the future role of implicit error. And we sort of presented this to our community. We asked questions like, could we use implicit error to modify the data, to modify the visualizations, or to even model systematic errors? And when we asked our collaborators if this is something we might do with implicit errors, they were very, very uncomfortable with that, as were we, because the official data is the official source. And who are we? What authority do we have to change the data? But we also wanted to know, could we even quantify these implicit errors that people were coming up with? Like, most of the insightful things that they knew about were hopelessly unquantifiable. And this question of should we? And when we presented this at the conference, the Q&A actually got quite pointed. Like, there were some people that were like really uncomfortable with us even suggesting that maybe implicit errors, enough of those, you could use those to model things like systematic errors, because this is all subjective, biased human knowledge. And we didn't know what to do with that, because the official data was like filled with problems. And yet our subjective knowledges from our collaborators was deeply insightful. So how do you resolve that? Well, I continued to think about this with some other collaborators at Utah, because we noticed these sorts of implicit errors coming up in all of our projects. Like, nowhere did we ever find a data set that was like, quote unquote, perfect. And the experts we work with were constantly making mental adjustments based on what they knew about the production of the data. So we started to ask, ourselves, well, what if we equally valued both data and the expert knowledge of our collaborators? Like, what would it mean to hold both of those things equal in our process of thinking about and designing new technologies? And what if we were able to then get many of these different kinds of perspectives? And how might that produce a much richer notion of this phenomena that we're actually studying? And so from there, we sort of shifted and started thinking about this more as data hunches. So less about problems with the data that we want to fix, and more about valuing the hunches and the knowledge that experts were bringing. And we thought, what if we think about visualizations as a way to sort of inspire and to help people articulate what they think they know about the data? And what if we give them mechanisms to actually articulate those hunches that they might be able to share with others, and to encourage others to come back with their own kinds of perspectives and hunches? So based on this, we built a small demo where we tried out ideas of what it might mean to implement data hunches in a simple bar chart. And we experimented with a variety of different ways of doing this. We found it was really important to have both the hunches and the original data together so that they could be looked at, they could be interpreted together, and yet you want them to be visually distinguishable since they are different kinds of perspectives. So we had these experiments, and when we presented this work, we got a lot of really the sort of reframing away from like fixing the data to thinking about how do we bring people more into, how do we sort of humanize the data science pipeline more, was something that really resonated with the community. And so just this past year, one of my current PhD students, Daria Baba, and I had the chance to really sort of think about this case study again from the perspective of feminist theory. So Daria and I have been collaborating with Lauren Klein. I don't know if some of you are familiar with her work. She's one of the co-authors of Data Feminism. We'd been working with Lauren for a few years to think about how to bring feminist theories into a visualization context and what that might mean. And in this paper, we specifically looked at the theory called entanglements by a researcher named Karen Berard. And we were able to use this this theoretical framework to sort of rethink how, to rethink the problem we had with implicit error, and to frame data hunches in a way that acknowledged data as produced, that gave space for people's knowledge to be situated and contextualized, and helped to understand what we later called the epistemic wall we had hit with the implicit error. So I could totally go deep into this paper, and if people are interested, we can talk about it more. But I want to just leave it at that for now, and move on to some other projects just to give a broader perspective of these ideas.
We are interested, but you can get to that later.
Okay. All right, great. Okay. So another recent project that this one is definitely work in progress, is around a concept that we call missingness. Okay, but let's back up. So this is Linköping University campus Norrköping, which is where I sit. Actually, there's my office. That is where I am right now. It's a beautiful city. These buildings here are filled with researchers and colleagues of mine in my department. But what makes this space really special is what happens in between. And in between is a public science center called the Visualization Center that gets about 200,000 visitors a year. And it is a museum space that was explicitly built on campus as a sort of research sandbox for people who are interested in thinking about how do we communicate science to the public. And so we have exhibits and we have a dome theater. And I think one of the things that makes the Visualization Center unique among science centers is that all of the stories that we tell about science are told through data and through visualizations. So it's a very digital and technological space, but it's an opportunity to think about how do we use data to tell these stories about science. So we have a lot of different kinds of exhibits. We have many different kinds of interaction modalities like touch tables and AR, VR kinds of equipment. But then we also have this very cool dome theater. And the dome theater was really designed to be an immersive space. And the kind of crown jewel of the dome theater experience here is a tour through the universe using a piece of software called Open Space. So Open Space is an open source software project that's been developed about over the last 15 years. I'm sort of here at Linköping University, but with some other collaborators at Utah and NYU and a few other places. And OpenSpace is a real-time rendering engine to visualize data from the Earth all the way to the edges of the universe based upon data taken in astronomical observations. So everything that you see in an open space tour is observed data coming from places like NASA and the European Space Agency. So for example, here we are zooming away from the Milky Way. We pass Andromeda, which is our closest neighboring galaxy. And we're quickly moving out to the edges of the universe. And each one of these dots you see in this view is taken from the Sloan Digital Sky Survey, which aims to map all the observable objects in the night sky, and currently has collected about 1 billion objects. And so using the SDSS data set, we zoom out to the very, very edges of the universe. And when we get there, we start to see some structure. And this structure we like to call the butterfly image, because it looks kind of like a butterfly, where you see these 2 wings emanating out. And when you go to an open space show in the dome, at this point, the narrator would be like, you know, we don't think the universe is shaped like a butterfly. And in fact, scientists are quite sure that at this scale, the universe is very homogeneous. But the reason why we see this black space, this void in the middle, is because that is the part of the universe that is aligned with our galactic plane. And using current instrumentation, it's impossible for us to observe through all the gas and dust and clouds in the way. So we have missing data. So these black voids that we see are missing data. And this got really interesting to us as researchers, because why don't they just fill in? Like, is there, why not, so that people don't think, so that kids don't come away thinking the universe is shaped like a butterfly, why don't you just fill in the gaps? And when we asked some of the scientists, we got answers like this one. Yeah, that never really was a question, because what we do is so tied to scientific accuracy, and our institution prioritizes that over everything. You're never going to see like an airbrushed Orion Nebula in our space show, which is typical in other planetariums. Like the artist just took an airbrush and made those clouds. We will never do that. We have a high bar in terms of scientific accuracy. And so it was really interesting to us that these scientists had such a strong commitment to the data, and instead of filling it in, used the gaps in the data as an opportunity to instead talk about the story in the story, basically how that data was produced, in order, in this context, to educate people about, well, like, where does astronomical observation data come from and what are the limits of it? And this is interesting because this is not the normative way that we think about missing data in data science and statistical contexts. Instead, we think about this notion of imputation, which is basically using fancy statistics to fill in the gaps. And imputation is the sort of standard thing that's done in data science pipelines when data scientists are wrangling data and getting it into a quote unquote clean and computable form. Missing data is one of the many things they have to contend with. And so people have developed a variety of different techniques to think about how do you fill in these gaps. One of the important things to consider for imputation is, what is the kind of missingness? Is it missing completely at random, in which case the data is just a subset of the full data set? Is it missing at random, in which case you could use the observed values to infer something about what's not there? Or this really difficult case, which is missing not at random, which is like, there's nothing in the data that tells you something is missing, so how do you even know if it's missing at all? Unfortunately, most of the cases are case number 3, which is why tools like standard data analytics tools like Microsoft Power BI and Tableau just drop missing values. They don't even attempt to fill it in. But still, yet we go along, we persevere, and we still work on imputation and how we can develop methods to fill in those gaps. And in the Viz community, people in the last few years have taken an interest in this, in thinking about how do we communicate imputed values with respect to the original. And so people have looked at various kinds of ways to visually encode imputed values. And they've done a number of studies to understand what are the effects of imputing on how people interpret data. What they find is that filling in the gaps fundamentally changes people's interpretations of the data. So the kinds of tasks that they have people do, their answers change quite a bit if there's gaps shown or if those gaps are filled in. Interestingly, what they also find is that when the gaps are filled in, and when they're filled in with visualization methods that make the imputed values look very similar to the original, people's confidence and trust in the data changes. Their confidence in their interpretations goes up, as does their trust in the quality of the data. So the more we fill in the gaps and the more we sort of make those gaps look a lot like the data that's there, the more people are confident in what they're interpreting. And our question is that okay? Like, is it okay that people think the data is of higher quality when we fill in the gaps, even when we tell them that those are filled in values? Is that the kind of thing that in all contexts is really the thing we want people to be doing? And so we've been wondering in this project, what if we accept data as it is? What if missing data was not a problem to be fixed? Like, how would that change things for us? And so we've been thinking about moving from this concept of missing data to instead thinking about the notion of missingness as a thing in and of itself worth considering. We think of missingness as exclusions. It's all the things that were excluded when the data set was generated, all the things that didn't make it in. And we're wondering how we could use missingness to inform different analytic interpretations, perhaps combining with something like data hunches to fill in those gaps in new and different ways. How might that impact how people interpret data? And that's as far as we've gotten. So one last small chunk of work I want to talk to you about is around this question of what is data? And I guess if I ask you all to just think for like 5 seconds, if like, what is data to you? Maybe we just all think about that for 5 seconds. My guess is that we're all coming up with maybe perhaps quite different sorts of definitions. And I think it's really interesting. I'm assuming everyone in this call like works with data on a regular basis. Like us as like sort of data professionals, we would have I don't think we could come to any consensus about this definition of what is data. And so then I'm interested in taking that into the public space, where data is something that's super important in everyone's life today, for better or for worse. It's also what underlies all the sort of quote unquote AI, things we used to call machine learning, and we now call AI. All these sorts of models that are really disrupting things right now are built on data. And yet our notion of what data is a really tricky thing. So how can we help other people grapple with this concept as well, to be more critical consumers? So with a postdoc, Charles, we've been working on trying to rethink, like as Viz people, how do we think about data as a starting point? And, a lot of people still talk about data as raw. I was just at a conference this summer, and I took note of every single talk that I saw that had some sort of pipeline. Okay, I guess Viz people love pipelines that started with raw data, and it was many. So this is still a concept we think about. Although I don't think most Viz people would think about their data, the data that they get, as genuinely raw and uncooked and unprocessed. It's just that we bracket away all that stuff that comes before the point that we get it. And instead, sometimes we think about data as ground truth. Like we run a lot of experiments, and in those regards, the data that we collect about, a variety of things is sort of our ground truth, that we have to be careful about how we analyze or process it if we're going to make claims later from it. A lot of us that do visualization design work think about data as input. It is the input into my design process, or I'm building tools like authoring tools for visualizations, and the data, I don't care where the data came from. I don't even care what the data values are. That data is just some sort of abstracted input. I care that it's a graph or a table. I think there's a lot of bubbling up work where we think about data as entanglements, and this is entanglement in the sort of feminist STS perspective. I think this is where there's a lot of exciting, sort of troubling things that we're starting to see in the community that go against our normative assumptions. And I think a really exciting and underdeveloped area is thinking about data as a design material. Like, what might it actually mean for us if we think about data as something that is shaped and shapeable? What is the role of data? And what's the boundary between data and visual representation? And this is where I think work in the data physicalization community has been super interesting in sort of thinking about this from a design perspective. But in one last project that I'm going to tell you about, we've been thinking about data as a rhetorical device. So what if the goal of data is not some sort of efficient analysis, but as a way for us to tell stories about ourselves? And here we were really inspired by the Dear Data project by this duo of designers, Georgia Lupe and Stephanie Posovic. And I'm guessing maybe some people here have heard of this project. And if you haven't, check out this book. It's awesome. It's just super fun to read through. And basically, this book compiles a year-long project between these two designers, where each week they chose some sort of theme in their life, really boring things like the doors that they walked through, or the number of times that they said, every time that they said thank you to someone, they tracked some personal data about themselves. And then on a postcard, they drew a visualization of that data and sent it to each other. And they did this, they conceived this project as a way for the two of them to get to know each other through their data. And one of the things, there's a quote from their book that I love, which they say, we've always conceived Dear Data as a personal documentary rather than a quantified self project. Instead of using data just to become more efficient, we argue we can use data to become more humane and to connect with ourselves and others at a deeper level. And I find this so interesting because, it's really about challenging this idea that the point of visualization is for people to, as quickly as possible, decode a number, and to instead ask, like, well, what if data is this like thing that we could use to, in wholly new ways? And in this case, as a sort of rhetorical device. So based on this, we've had an ongoing collaboration with a group called Stads Mahun, which is in the American context, I would call it a social working organization, but it's basically a social innovation organization here that works with people in vulnerable areas of Sweden and provides a whole range of different kinds of services and opportunities for people to help them integrate into Swedish society, and also to help them build longer-term tools and techniques for themselves through empowerment. Okay, so we're working with a group. We are working specifically with our collaborator, Martin, who works with a group of teenage girls in one of the vulnerable parts of our city. And he has an a 1.5-year-long leadership empowerment program. And we got to talking with him, and he was really interested in, can we find new ways to empower people, and in particular, these teenagers? And my student, Daria, and I said, well, what if we could think about using personal handcrafted data for reflection as a different way for people to learn about themselves and learn about their communities? Oh, and I like to point out in this picture, you can see me like clutching my Dear Data book because I love this book so much. So it was like the source of inspiration for this. And so what we did last year was we designed a series of workshops to sort of explore ideas of what would it mean to work with this group to collect their own data, but also to think about non-digital ways for people to create and interact with visualizations. So we created something that we called data selfies. Our workshop 2 was about data jewelry, and the third one was about emotional mapping. And based upon this, and so we ran this, it was a group of about 12 young women that we ran it with over the course of about 4 months. Based on that, there's a variety of follow-up work that we're doing in that, and all kinds of good lessons learned. But this has also been our chance to do our first exhibit in the Visualization Center, which I'm super excited about and is going to open up in 2 months. And so in the Viz Center, we've been given this prime space on the ground floor where we have a new exhibit called Data and Me that is sort of inspired by a lot of the things that we sort of learned and tried in these workshops, that is really meant to bring a very complimentary view to our visitors at the museum about what data is and how it relates to us personally. You know, everything else in the museum, the data sets tend to come from scientific equipment and sensors and things like that. Whereas here, we're sort of pitching this idea of like, anyone can create data. I can create data about anything, like the candy I ate last weekend or whatever. And to give people like simple tools such as data jewelry and things that they could do to sort of encode that data in new and interesting ways. So again, this is work in progress, but this is one of the outcomes of this collaboration that we're pretty excited about. Okay, so wrapping up. I just wanted to put I love this quote, staying with the trouble. It comes from Donna Haraway, who's sort of a, sort of seminal figure in modern feminist and STS theory. Her notions of staying with the trouble is really a sort of invitation for us to think about, finding places of trouble, of tension, of strangeness and uncomfortable and uncertainty, and sort of saying that it's perhaps these moments that are the places that are really ripe for new knowledge creation and new opportunities. And I think that's a really good theme for my group and the kind of work that we're pursuing. Is about finding these points of tension in visualization research. And instead of just trying to like clean things up or smooth things away, asking, well, like, why? And what might it mean to look at the problem from a different perspective? And that's kind of the theme of the work that we're doing. And so with that, that's what I have. Thanks again for listening. And I am really interested to hear what you all think about this stuff.
Super cool. Thank you very much. I see there's spiritual applause. Yeah, thank you. This is amazing. I see hands. Is there also hands up? Okay, Mila Oiva.
Yeah, hi. Thanks for sharing all this very interesting and intriguing research that you're doing with your colleagues. I think it's a question rather, but it's also a bit of comment as well. So my background is in cultural history, and I'm working with different kinds of data, and I kind of like really loved the way you describe this missingness, because it's really something that I kind of like, well, in general, I get excited about data, but I get super excited when I see some gaps, and because often it kind of like tells me something about, kind of like, usually it's something about the creation process of the data set and how it, who did it, how it was made, and so on. In my field of research, and especially if we think about kind of like cultural heritage data that has been often digitized, I, of course, as a historian, I see it as a kind of like a historical process. So the data, perhaps somebody just collected it first, then it went into archive. It was historically arranged in certain ways. Then there are these different other processes. Perhaps kind of like some data was transformed into microfilms, and then later on there are these digitization processes and so on. So I kind of like see data also as kind of like a series of historical layers, or that there are certain kind of like temporal layers behind there. So I was just wondering, have you been kind of like thinking about or perhaps using this kind of like these layers in a way to tell about this incompleteness or missingness of data? For instance, just, I don't know, just to a way to create these historical layers of how we have been perceiving the universe and how it actually change, how our understanding has been shaping in many ways, or of course, data often comes as a collaboration, so it's not only one person, but it can be a kind of like a network of people collecting in different ways the data, and kind of like would it be possible to create or kind of like visualize this data as a kind of like collaborative effort and emphasize this part? I don't know if this makes sense at all to you, but
Yeah,
I was kind of like inspired to talk a little bit, you know, think out loud with your super interesting talk. Thanks.
Yeah, thanks for that. Like, I love this idea of the layers, and I have to say, in my mind, I do often think about when we talk about the concept of missingness, I think of it as sort of like an onion with all these layers. Because, you know, theoretically, you know, I like to think of missingness as exclusions. It's all the, you know, if data is the sort of thing that was produced, missingness is all the exclusions. And when you start unpacking, you know, is it because of sensor readings that were down, or is it then because of the resolution of the device, or is it because of who did it and who didn't do it, or is it because, like, there's you get into these layers, and then you start talking about history, and we didn't even think about recording this thing because we didn't think those people were important, and like, right, so it's all these layers, and I, you know, I should have said up front, like, like positionality. I am trained as a computer scientist and an engineer. And so, you know, I think about this notion of layers, and it very quickly makes me very anxious. And I'm just like, what? It's like infinite, and like, how do we actually create something for that? And as I've kind of struggled with that, it's got me thinking about how much my work and the work of like my community is largely constrained, because when we think about data, we think about digital. And when our sort of main sort of material for working is computational. And that puts such restrictions on what gets to count and what doesn't. And I think that's also, you know, I didn't go into that, but this is something I've found really interesting with imputation and reading about imputation and arguments for it, is like when you sort of read around it, you see like the whole point of like cleaning data and turning dirty data into clean data and filling in the gaps is simply to make it such that it's a form that's useful for a computer. Like, it's not about us, it's about the computer. And it's like, is that really like what I think is the data really just about the computer? Is it about us? So I sort of, anyway, point is I think that, like, for someone like me, my mindset instantly comes from a place of like the computational medium. And that's also why I'm interested in starting to explore non-digital versions of visualizations and data, to sort of think about like what sort of affordances and opportunities do we get if we are no longer constrained by things that are computable. And that's where your ideas about layering and the fact that you would so sort of like naturally think of it that way, for me, that's difficult because I don't know how to compute that. But it would be super interesting to sort of play with that and see where it goes.
Super nice. Any other questions? Yeah. Sure.
Yeah. So hi, I especially love your talk because it resonates with a sentence I was reading yesterday, and I've been thinking about this for a while now. The sentence was more or less like, when we start paying too much attention to the boundaries, we start paying less attention to the complete picture. And for me, data is a lot treated like that, especially practically speaking. Maybe even outside of the world of computation where you need it as an engineer. I think we grab onto data as something we need as human beings, like categories that we need to basically make sense of life. But then that's where we do lose focus of the overall picture of what's going on. So especially in academia, how do you actually try to find that balance, or how do you strike that balance, or how do you convince people around you actually that there is such thing as missingness or as incompleteness, you know?
Well, we haven't published any of this, so I have not yet done that vital step of convincing other people this is interesting. But no, I mean your comment, I really I understand your feelings, because I also have these ideas, there's that, the famous book Sorting Things Out. I don't know if that's sort of what you're referring to, this sort of look. I don't know how old that book is now, maybe 20 years old, but really unpacking what classification does to our representation of very dynamic things in the world. And this is even related to what we were just talking about the sort of, the very strong constraints of the digital and the computable. And I guess sometimes after reading a bunch of articles about tech bros, and I start to get angry, and I think, who sold us this bill of goods that data was going to like solve all of our problems? Like, what? Because, when you start to think about data from these critical lenses, you see just how shallow and flawed and partial data is. And yet we are starting to build so much important infrastructure and decision making on these things. So what's the answer? Great question. We need to all think about this. On bad days, I'm just like, oh, let's just give up on data. Like, what if we no longer had to worry about data? But obviously, we have some pretty major things going on in the world that we can't just rely on our sort of limited human capacity to think through things. So I don't know. I find it very overwhelming sometimes. And in those moments, I guess I go back to my research, and I've been very sort of lifted up and sort of feeling better when I feel like just knowing these things about data helps me to sort of see problems in new and different ways. And it just leads to doing slightly different kinds of research. And maybe if, enough of us take these perspectives and approach data analysis challenges and research in a slightly different way, then eventually we end up in a different place than we would have otherwise, which is a very unsatisfying answer. But I totally understand those feelings.
Thank you.
Yes, Mike.
Yeah, thank you. It was really fascinating and sort of.
Can you speak up a little bit?
Okay, is it?
Yep, I can hear you.
Can you hear me? Okay. Basically, it sort of resonated on many levels. One question I wanted to sort of ask you to elaborate. Do you think there is some sort of thing you can call good practice in treating this missingness thing in the end? So as a result of what you thought about it, and more or less similar thing about, biases in the data, for example. Speaking of your first story, we all seen that, for example, with COVID data, if you don't allow for this biases and collection of data in different places, the data is completely misleading. Yes, it is. You cannot interpret it without sort of cannot interpret it in any reasonable way without allowing for these biases, and you need to there are indeed cases where you cannot avoid this sort of qualitative addition to what to the data. So do you think you can recommend some sort of practices as a result of that?
I think that is great future research. Other people should think about this too. So no, I don't think we have anywhere close to standards for this. Well, let me sort of two responses to that. So one, we've been doing a follow-up interview study around our data hunches work, where we interviewed a bunch of data professionals, all the way from like science researchers through government workers and public health experts. So we interviewed a lot of different kinds of people about their experiences working with data and about data hunches and what do they do about it. And of course, like everyone's like, no data's perfect. And we're like, yep. And yet that's, I feel like at least in computer science research, and I don't know everyone's background here, obviously it's quite varied, but even though we would all say we know data is not perfect, it's still kind of our underlying assumption that data is going to be perfect, and we sort of build from there, whether it's building models or tools. And so I think, first of all, we just, trying to be more clear-eyed about that and thinking like, if we assume data isn't perfect, then what do we do? I think is an interesting first step. But one of the things we learned in these interviews, because we asked people like, everyone's like, yeah, sure, there's all kinds of caveats that I think about when I interpret my data, is how seldom any of this gets recorded. And, some of the scientists would say, well, like we try to keep good lab notebooks. And then when we publish our papers, we, have footnotes and caveats in the paper. But in so many other contexts, when there isn't some sort of like reproducibility requirement, this stuff just gets lost. And, and it's not even just a matter of like, it's not even a matter of people being like, oh, I can't be bothered to write it down. There's cases where people, there's like these difficult, like cultural things where it's like, my manager just wants an answer. They don't want to know about all the caveats and it could be this or this or this. They just want a yes or a no. Or, I need these decision makers to sort of trust me. And so I need to just present this as confidently as I can. So there's like all these like complicated things that I think sort of are part of all this. But, from a different perspective, I do think that there are initiatives that we've seen for thinking about how to capture these analysis pipelines. And if you think about the whole like rise of computational notebooks, Jupyter and things like that, these are very much platforms that are acknowledging the need to more faithfully capture what happens in data analysis. And, in the visualization community, there's this whole sub area around provenance. How do you track provenance, when people use these interactive visual analysis tools? So there's this interest, and I think that there is interesting work going on that seeks to try to capture some of this. But on the whole, like we all use so many tools, like these tools, none of these tools were designed with a layer that's like, great, now add your annotations that will get carried along through the entire analysis pipeline. And I'd argue, I think part of that is because one, it's hard, and two, in the sort of computer science technology community, we just sort of build from the assumption data is perfect and go forward. And, everyone else who has to work with imperfect data is just like, well, I got to do something to get it to the point where I can work with this thing. So not a clear answer, but I do think that like, I see a lot of interest in the sort of human in the loop, and especially with we're talking about AI systems and stuff. And I think these are all things that people that people are kind of understanding might be necessary. But how we do that, I don't know. But I guess that's why we're all like hopefully going to have careers for the next decade and beyond.
Sure. So I just want to ask a follow-up on this, maybe like, because when you go through the data science course, the very first thing you learn is in NumPy or Pandas, you have fill in and drop it. And those are like so embedded in the language already, we have the tools to drop the data or fill it in, but we don't have anything like, okay, missing this, let me appreciate the missing part of the data, let me appreciate the outliers. But now I hear that more people are thinking about outliers differently. But what about the actual practical tools that we are using to bring data into our real lives or visualize it? Maybe there could be something we could do there, maybe potentially.
Yeah, absolutely. And and I think the sort of pointing out like the words that we call things, like there's the whole tidy data like thing that happens in R. And tidy data, is data ever tidy? No, but 80% of your time as a data scientist is going to spend making it tidy. the words we use, I think, are kind of a red herring for these assumptions. And that's one of the things that I've gotten really interested in is how, you know, we as like engineers and technologists could do this sort of more cultural work and sort of look at the words we use and think about our underlying assumptions and ask, do those assumptions still make sense? But yes, absolutely. Like, what would it mean to like work in an R pipeline while trying to capture like data hunches? No idea. I would love to see some investigation on that. That would be super cool.
Super awesome. I cannot tell you at how many levels the whole talk sort of resonates with what I've done since my PhD and even before. You know, I worked on 650 years of building reconstruction, working on tens of thousands of drawings, which are all sort of like looked in person. And then there's these databases of monument documentation for sculptures and for architecture. And what you're describing is really interesting for this to swim up right now because it's going on for centuries. It's crazy. And I can give you a number of examples. There is for completions, right? So if you have an ancient sculpture or architectural drawings and you want to reconstruct the building, there's a thing called the Venice Charter for sort of cultural heritage objects that if you complete, you actually have to do it in a way that you can actually see what has been completed, right? But there's this interesting thing that, you know, this is done by famous architects or famous whoever, and then they get a copyright on their reconstruction, and that becomes a thing by itself. So you cannot change it as a museum curator and stuff like that. So there's a whole long story regarding this. And then this is not only in art history or in archaeology where people sort of annotate drawings, but there's actually even going on in the sketchbooks themselves. Like if somebody does a sketchbook in the 1580s, say, of a ruin, and then somebody else inherits that, somebody else famous, like Borromini had all these drawings from the 16th century, for example. And of course, the later generations, they just would draw into them. And they would basically say, this is this and that, or this is that ruin. And so basically the meaning changed, but other people sort of like, you know, erasing stuff, copying selectively, and then recompleting that again. I actually have a talk about this, which I did in 2005, which mea culpa, I didn't publish as an article yet, which is called the cycle of sample and remix. So basically we have evidence for all the steps in this sort of like grand master series of sample and remix and everything that can go wrong, which obviously also has a feedback loop, which is quite crazy. And I think that is sort of like, and you really nicely pointed out, this is nicely in contrast with the original book you showed in slide 1, where you have this, yeah, there's a feedback loop, but in the end, you want to get to something, right? You want to get to some insight. So if you follow Card, McKinley, and Schneiderman, you get this sort of, you know, information design has a goal, which is the design that gives you the insight. And one of the interesting contentions, which I think is really, really cool, is that Card, McKinley, and Schneiderman has been called by the economists, sort of like shortly after it came out, as the sacred text in the field. Okay. And this is like very much how we treat it, right? Like it's this sort of like, oh, you want to learn how to do a tree visualization, you have to read, you know, Schneiderman, whatever. And then if you want to know how to do a matrix visualization, you look up Jacques Bertin. Okay, mea culpa, I said that to somebody today on the internet. But, you know, where do you find that for a broad audience? In that book. And so it's more or less like the Bible. And so now there is this kind of like contention that the longer we deal with data, the more we find out that it has these contentions, it has the missingness. And then there is this long process of things like refilling and remissing and re-deletion and putting in stuff together and stuff like that. And that becomes then sort of the main activity. And I think that is sort of something which you really platform in a nice way. I think the only sort of like way forward with this is indeed you know, what you quote as feminist theory, where you have these sort of like notion that, yeah, oh, there is multiple perspectives. It's all performative. It is, and, you know, Ernst Cassirer in 1910 would have said it's functional, not substantial. So there's no such thing as a fact, but it's all just part of generating mechanisms, which are perceived by different people in different ways. And so that is sort of like something which I think we need to get back into the crowd, which, now let me say an evil term, seems to still be very positivist, where people think, oh yeah, that's the data, which is a picture of reality. And if I do XYZ process, I get the answer, which it cannot be, obviously. And so the question is now, how do we sort of like get that in the door? Because there is this whole history of things that happened. And, you know, if you want to sort of like put it in historical terms, we have outed ourselves here, the whole group, everybody who spoke towards your approach, as like sort of like, you know, Cardinal Ratzinger would have said bloody relativists. While then there is also this sort of belief in sort of like, you know, even implicit, that sort of some truth can be put out of the data. Like, for example, yeah, you could have an AI decide if somebody, let me be blunt, needs to die or not, like on the hands of a data integration company that supports somebody who does genocide in some region in the world, right? So the question is like, how do we actually get this message as broad as possible and soon enough to the people who need to know it?
Oh my gosh. Wow.
Sorry.
No, that's a lot to think about, and I love those perspectives that you're bringing forward with your sort of previous work and thinking about how that's like so different than where we are now. You know, my cop-out answer is that, hey, I am lucky that I have like a whole science museum that I get to do research in and to like actively think, well, what would it mean to engage people in different definitions of data, and that's certainly what we're trying to do. But there's another project that we have that's sort of situated in the museum, but I'll throw out and see like what you all think. It's a brand new project. I have a new student working on it. One of the things we notice over there is that there's no names on any of these exhibits, and you know, when I visited other science museums, like there's not, when you do have some sort of like digital thing, there's no like long list of names, like how does digital technology come to be? Well, there's programmers and there's data producers and there's like content creators and there's designers and then, oh my gosh, there's maintainers. There's people who have to like maintain this stuff. Like there's so many people involved with technology. And in our science museum, like other science museums, these things are presented, well, in a sort of feminist way, like, you know, God's eye view, right? You have like a cool touch table where you can look at anatomy using different kinds of volume rendering techniques, and that's neat. But it's sort of this like view from nowhere, right? And so with this new student, we're really interested in this notion of credit, right? So we're starting from this perspective of like, what would it mean to give credit to all the various people involved with creating exhibits? So we're starting by doing some interviews by, you know, we have all these different people who do all these different roles in the museum and trying to understand what credit means to them. And turns out it's a very complicated thing. But, you know, when my student Kate and I talk about this and we try to, you know, sort of speculate a little bit about like possible broader implications of things we might learn, I think it's really interesting to think about most of our technologies, like anyone who's writing programs or creating visualizations in general, we don't like put names on these things. And, you know, like the tools that I've created, and sure, like I've thrown them up on the web, other people can like download them. Like there's no like names of like the people that were involved, and there wasn't even necessarily deep thought process about like, well, if I built on this library, does that count as contribution? Was that part of the crediting that goes in this, and these sorts of things. And so I think, you know, this is not the answer to your question, but you know, this is another kind of project that I think is, you know, what if we try to humanize like the work that we do as technologists? Would that move the dial in people's perceptions of like what technology is and where it comes from? I don't know.
That is
I mean, the situation you described with your layers of patents and things, those names kind of go along, they sort of follow along, and this notion of creation and ownership kind of like bubbles up, but we have sort of dropped that somehow when it comes to digital technology.
Yeah, this is a very interesting point, I think, very interesting direction to discuss this. So if you think about it, like in Renaissance times, the actual people who have done the groundwork of measuring the ruins, often hundreds of drawings of the same monument, they typically are completely unknown, and you can only estimate how many hands are involved because there's different styles of drawing, whatever. But obviously people may have a headache one day or on another day broke their arm or whatever. So we don't really know. And then the people where we do know, like the famous people who've done the famous sketchbooks, they make mounting mistakes. So they combine the fragments, and we know they were not the originators because they actually just copy drawings and don't understand the ruin. So that is sort of something which is quite interesting. And you see the same thing, you know, like my favorite example is the Kraftwerk video, you know, Music Non-Stop, which is very well known as a very well-known single author. But she's not the only person who was involved in the whole construction process. So there's a whole bunch of people obviously involved in whatever 3D scanning takes in 1981 to 1983. And so that is sort of something which is quite important, that we need to sort of like really deep dive, like Ruth Arnott has done, for example, for this Protestant letter networks and so on, like into the material and in the Living with Machine projects of like who was really involved, you know, because we don't solve the problem of mentioning the hidden figures when we mention just Ada Lovelace. There's like many other people, male and female, people who, you know, the equivalent of forced labor, whatever, to come up with something like that. Mm. And then there is one other thing, like other than these things that cannot be reproduced, like you probably could not trace all authors of all sort of aspects of whatever we do. On the other hand, there is this attribution problem, because attribution itself is also data, and attribution is subject to distortion like any other piece of data. And like there, my favorite example, if you take the escalator in the Ross Perot Museum of Natural History in Dallas downtown, you sort of like go up several floors, and there is this sort of quote coming at you, which says, "Earth is 4.3 billion years old," in quotation marks, Linus Pauling. Which is like, you know, Linus Pauling is like, yeah, he's a great biologist, but he's not the guy who said that first. And there is actual evidence, right? So this is like as hard as you could probably get with a fact in terms of dating how old the planet is. So this sort of like making this a quote to sort of like, you know, so not enrage sort of 80% of your audience, which is fundamentalist Christians who live nearby, is also sort of like questionable. So that by itself becomes a problem, which is why citation networks are so interesting, right? So there's all this like Matthew effect and whatever thing going on.
Mm. Yeah, totally. What do you know, what do we do with that?
Yeah, I think, I don't know, would you agree that like the best thing is like, you know, once you realize that it is that fluid and liquid and contentious, that's where the fun begins. Like that's where we will probably never get a full big picture, but we can sort of like see, you know, where it can go wrong and how it can be right. Like, you know, if you have triangulation of facts, like there was this fake news video by, you know, supposedly Volodymyr Zelensky said something, but it was like literally a puppet on, like a head on a puppet. And then he sort of walked out and took his cell phone and like, you know, panned around, and you could hear all the noises and everything was consistent. And that's what people accepted as sort of like the real video, even though it was also just a video that was recorded. So in a similar way, this may be a way that we sort of like have to deal with data, where we have to sort of like show how it is traced and stuff like that.
Mm. Yes, which this is like the third or fourth time in this discussion that I've thought about uncertainty. But I'm gonna just stop my screen sharing just because I'm realizing maybe you guys don't need to see that.
Sure.
Okay. Yeah. So one of the things that, you know, once you sort of see the world, as you say, in this kind of like fluid way, you can't unsee it. And I find that very exciting too, because everything looks fresh and new. And, you know, when it comes to missingness, but just even this broader perspective on data and technology, this often takes me back to the notion of uncertainty. And so, you know, visualizing uncertainty is something that the Viz community has been looking at literally for decades and for many generations of students. And many dissertations have been written about like, how do we visualize data uncertainty? And yet we still don't really know how to do it. Most visualizations you see do not include it. And like, it's still this completely unsolved problem. And so I'm not saying I have the answer, but like, I'm really interested in like, well, maybe it's time to start thinking about uncertainty as this very precise thing that we want people to know that this is exactly an 87% confidence interval. Like, why do we need to be so certain about uncertainty? And furthermore, what is the role of uncertainty? Like maybe uncertainty is to make people uncertain. And if the idea is like making people uncertain, I feel like us as sort of technologists and data professionals, like if we know that data is inherently all these things, it's uncertain, then maybe the role of uncertainty, maybe uncertainty is really a tool for us to communicate to others, hey, caution, beware, like this data is not perfect. You need to proceed in your interpretations like carefully. And so from that perspective, maybe uncertainty is about making people feel uncertain. And, if we want to make people feel uncertain and uncomfortable, how do we visualize it? I don't know. I haven't seen anyone like they all do studies on like how accurately can people like decode your probability distribution function. They don't do studies on like, did I feel really uncertain when this has a 35% confidence interval? Anyway, the best example of this I have, and sorry, this is a very US centric example, but it's a really cool example and it's worth looking up. So in 2016, the presidential election between Hillary Clinton and Donald Trump, this was also, I think, about the time that there started to be a lot of this prediction, polling prediction stuff that was coming out. 538 was this like new like statistical site where people were just doing all of these like predictions on the election and all this stuff. So this was a pretty new thing. And so 538, which ended up being one of the sort of more prolific prediction outlets looking at the presidential election. It was run by Nate Silver.
Yes.
Nate Silver, yeah, thanks. They came up with the election needle. Now, the election needle is basically, it's like a half circle, and one half is, half of it was for Clinton and it was blue, and the other half was red and it was for Trump. And they had a needle. And the needle was supposed to the needle pointed on any day or hour to what the predictions, what their models were saying, which way the election would go. And so in the days leading up to the election, the needle's kind of like swinging, and it's like swinging a lot. And so in interviews later, you hear Nate say things like, yeah, we were encoding the uncertainty in the sort of movement, the jittering of the needle to sort of give this like visceral like reaction, or this visceral feeling to like the models didn't know what was going to happen. And I can say from a personal experience, like being very stressed out about this election, watching this needle go like this, I'm like, oh my God, are you joking? Like, how can it be like this? And on election day, it starts like this. And as the night goes on, it's like, and it just stops moving, at which point, we know what happened. And this needle was so effective in making people feel anxious that there was like all these memes on Twitter about this, and there was like lots of like hate, a lot of hate about the election needle. But I thought it was so interesting because it did exactly what the creators wanted it to do. It made people feel very uncomfortable with the prediction results in a situation that we wanted certainty. We desperately wanted certainty. Eventually we got certainty, and it wasn't the certainty that many of us wanted, but for some people that was a very joyful outcome. But we wanted certainty. And so anyway, I think a lot about that example and like the power of that example, and like what if we took that perspective when it came to data and uncertainty more often, and we just try to literally make people feel uncomfortable and uncertain as they're working with data. I don't know. That's something I've been thinking about a lot.
Yeah, I think it's a very excellent sort of like perspective, because actually this is usually not transported, right? Like you're presented with an election map, but you're not sort of like presented with the swinging back and forth. Like I mentioned this before we started the session. Like, you know, you living in Utah, I lived in Texas. I lived in a swing voting district of Dallas. So we had 85% Trump in this election and 65 Beto, which was a Democrat, and then 65% Trump again. And that was exactly that, what you experienced when you walked around in your neighborhood. You got this swing by talking to people, and they were like really undecided. And you could, you know, I'm afraid to say that this election was less surprising for me than it was to my Boston colleagues, which nevertheless was as depressing. But that kind of thing is sort of something that is usually not transported. And I think one thing which ties back to a number of other sessions, like 2 weeks ago, we had Carl Bergstrom and Chevin West, and a week ago, we had Vittorio Loreto. What came up is this issue of noise in data and uncertainty, which is one of the most, you know, the used assets in like current political influencing. Like, you know, basically when people say one thing today, another thing tomorrow, what they do is they play with the noise knob of the system. So not only is uncertainty something data has, it's actually something which is actively played with. And as such, obviously, we need to sort of actively show it as.
That's so interesting. That is so interesting. I mean, and that gets to this, that sort of, I think, feeds into this notion of data as kind of like a design material, or the uncertainty. It's a material that we are actively trying to shape. That is such a cool example.
Have you heard about, like, there's one area which like comes to my mind that is sort of related to your different forms of missingness in the data, where people sort of routinely do this without asking because they don't have to go to InfoWiz and ACMG, which is this field of species niche modeling, where obviously, you know, if you have data in France is obviously you know, collected in a different way than in the German Democratic Republic, than in Western Germany over 50 years. And in one country, you have like 50 kilometers squares. In other countries, you actually sort of count where the bird was actually seen, which is usually at the birding spot and not like, you know, not sort of like distributed in a nice way. In other countries, this is randomized. So you get this patchwork, and it very naturally emerges from them. And they had like, there's this, I think his name was Jorge Soberon at the University of Kansas, who has a whole book about like how to deal with this issue, because it seems to be so bad in species recording that is basically what they do. But one of the interesting thing is, it seems to me, like based on what you were saying, that they were charging ahead because nobody was putting them into question, and they just needed to deal with this. And that reminds me of biology, and I'm pretty sure you know a lot of like cases in biology where people do similar things, like how do you deal with noise and missing data in, I don't know, yeast to hybrid versus literature curated or whatever. Could you speak a little bit to that, because you have a lot of experience in that area?
I mean, the first thought that just comes to mind, yeah, it's just how subjective the whole scientific process is. Again, it's this thing that once you see it, you can't unsee it. And, you know, obviously scholars have been writing about this for decades. But I think also, like, I just, you know, if I'm going to critique my own community, I just think that as we have built these technological tools, whether they're small and bespoke or things that are open source and have a huge like number of people using them, they're built by, they're not built from this really, I see, very authentic view about how science gets made. And instead it's built from a bit of a sort of idealized way from the way that science is made. And I think by having that idealized way, like, we don't give space and mechanisms for people to be able to sort of record their process or work in that process in ways that is more fluid. I don't know if I can be like super articulate to your question, but I I look at the tools that we have, and they're not designed to account for the very humanness of what we do when we work with data. And, you know, I had this experience this morning. I was giving a lecture in a colleague's class, and I had to give this talk about like, it's like master's students who are going to start writing their master's theses. And so I give a sort of overview about like, how do you start thinking about putting together a technical piece of writing, right? So I have a bunch of tips and tricks that I use in my own, for myself and for my students, and we talk about that. And one of the things I like to talk about is like when you, as the sort of author and central research figure, how do you write about yourself in this report? And we looked at, I bring forward this, we look at this paper, a very well-cited paper in my field that was written by a solo author, which is fairly unusual. And in the intro, you know, we just read the intro and she uses I, you know, she doesn't say we, and she doesn't say the, you know, she doesn't say, you know, the work or whatever. She uses, you know, this is what I did and this were my contributions. And the years that every year I've done this, the students are so uncomfortable with that. And they always come back to the same thing. Like this morning, one guy was just like, well, you know, it was really hard for me to read this. And I kept fumbling over the I and the my, and it just felt wrong. And I was like, well, what would you have been more comfortable with? And he's like, we. And I'm like, and I said, but why? We know it was a solo person. And if you say we, that's not actually accurate to like what happened. He's like, well, that's what we've been taught good science is. So of course, I feel like my sort of role in this class is partly to let them know that you've been taught to write in a certain way, but that, you know, all those rules can be broken, and perhaps for thoughtful reasons. But it's just like, this is just like how we, you know, we have these assumptions about how science works and what good science is, and we go along our merry way, regardless of whether or not that's actually what we're doing.
We have one thing that we'd like to come back to, which is entanglements for visualization. You said like you could talk more about it. I think this would be particularly useful for the cultural data analytics community because it's really a missing aspect. You know, it's something that is discussed with people who are invested in it, while it's not discussed by other people, but everybody should know. So if you could give us like sort of like a 5-minute summary of what you think is important there, also within this respect what we were talking about.
Yeah, it's a great question. And how do I answer that without like going so deep into details that perhaps are not useful? So I'll just say personally, the sort of theory that we grounded that work in is this entanglements theory, or a gentile realism that is the product of Karen Berard. She has a book called Meeting the Universe Halfway, that, you know, at least my STS scholars tell me, you know, it was like the next step from Donna Haraway's Situated Knowledges. Entanglements came out as like the sort of building on that, and that sort of modern feminist materialism and new materialism builds from this entanglement of Karen Berard. So this book was written in the early 2000s, and it came out, so Karen Berard is trained as a theoretical physicist, and in fact, they were a professor, I think, at Columbia for quite a few years in physics, as they were developing these philosophies. And they ground their ideas actually in this very philosophical writing from Niels Bohr. And there's some very specific thought experiments that they go through that people put out, you know, in trying to deal with the unintuitive aspects of quantum mechanics. And when my bachelor's degree is actually in astronomy and physics. And so like when I read about this, for some reason, you know, grounding it in science really did something for me. But in bringing forward these thought experiments and pointing out this sort of potential deep philosophical implications on how we make knowledge and how we decide and people decide what matters and how those decisions actually make things matter, it really, really made a lot of sense to me. And so Karen Berard's theories sort of like stem from that sort of, you know, philosophical quantum mechanics thinking into this whole worldview about like, well, what does it mean for knowledge to be made. And, you know, they sort of talk about phenomena as these dynamic entanglements that are, you know, constantly in the making. And it's when you have some sort of measuring apparatus that intersects with that, that you get this sort of momentary static, what she calls a cut, what they call a cut, and what, you know, we sort of refer to as a knowledge artifact. This thing that is a product of both the phenomena in the world you're studying, but also the apparatus that you bring to it to study it. And so I think about data as one of these sort of knowledge artifacts. And, you know, data that's meant to, you know, represent COVID. Or let's talk about the census data. We use that example in the paper. You know, census data is meant to represent, you know, the population of people living within some sort of country geopolitical boundaries. And, you know, how does census data get made? You know, it's made based upon, like, you know, a bunch of different methods that occur over some period of time that are all imperfect. And yet at the end of the day, you get some number like the population of Sweden is 10,149,367. I mean, I don't know if that's what it is. It's around 10 million, but if you looked up the sense, you know, the population of Sweden, you'll get like a very precise number. But what does that precision even mean? And it's because that number was produced based upon a very specific set of things coming together to measure something that itself was also very dynamic. Where am I going with this? So anyway, her theories I find to be just really, for me, they were very wonderful to relate to. And I thought were a great thinking tool for thinking about how data comes to be and the challenges we have with it. And also thinking about sort of our role, like thinking about visualizations also as like a knowledge artifact, and how those things happen, and how all the people that we learn, whether it's Breton and Schneiderman, or maybe it's totally different. And it's, you know, like people like Isabel Morales and people that come from design, like these are very different people who would influence the way you create visualizations in different ways. And my visualizations are a product of all that. And so, the entanglements paper, sorry, let me like pop up here. The entanglements paper was meant to do the kind of what I considered several years worth of very hard lifting of trying to take this STS writing and transform it into something that made sense and took into account visualization matters and concerns, namely data, visualizations, and insight. And then sort of tried to talk about, like, what are the implications? Like, you know, another part of this paper is in a strong advocacy for not a single epistemic perspective being the one, but instead that a plurality of perspectives, some of which are positivist, some of which might be relativist, some of which might be feminist. And what we do is we try to highlight how this perspective opens up new questions for us to consider in the Viz community, not so much that those are the only questions that we should consider. So yeah, and then we use this implicit error to data hunches actually as a case study to talk about how a shift in our epistemic foundation changed the way we thought about this problem, because it's really the same, it was the same thing we were interested in, both of those projects, but we came to it with a very different value system in each of those, and it led to different results. And so that's the argument we make in the paper, is that these different epistemic foundations can give us different research. And when you put all that together, it makes for a richer research landscape.
That is really cool. I think this one interesting thing, like STS, for those who don't know, means Science and Technology Studies, right?
Yes, thank you.
So no worries. It's just like our audience is really broad. And one of the interesting things is that in STS, and you know, I'm probably not considered part of it, but I think work I have done is relevant in it, and so I self-identify with, you know, in some ways with that. But so one of the interesting things about that is that there you have a greater awareness about this thing that, like, you know, observation can only be done with measurement instruments, and measurement instruments are faulty, just like our eyes are measurement instruments that are now faulty, and there's cognition going on. There's like all sorts of weird stuff happening, and we're sort of used to this kind of thing, while the physicists often try to get away not also doing that. But I think there's a rather interesting new stream of sort of like researchers who are more aware of this. And
Mm.
so we had a board member in our project called Julio Tino, who was the Dean of Engineering at Northwestern University. And he has he does these talks where he talks about like a history of mathematics, history of physics and stuff like that. And one of the interesting things he brought up once was that Niels Bohr was actually in an office with a cubist painting. And that's a really interesting thing because that signifies seeing the world from different perspectives at the same time. And so there is this sort of like bridge to Poincaré, who didn't draw, for example. There's like all these weird sort of like notions of like, oh, okay, it's like, how does this actually come to be? Like, how does, you know, how does sort of like our modern notion of how we visualize, how is that rooted in people who actually came up with these ideas? And it turns out the people we think they're like, you know, sort of full up positivists, obviously Niels Bohr was not a positivist in this sense, right? And so that is a really interesting thing, which seems to sort of have gotten lost over time. And now as a maybe, you know, sort of like undergrad student in physics and computer science, you can get more away with being a positivist than a physicist in the 1920s and 30s, where, you know, Planck gave a talk in 1930 where he said, you know, actually, to assume there's one real world is a metaphysical step we need to take. So we have no proof, and all our measurements, they all tell us something different, and our measurements don't fit together because they're all wrong, and they're all sort of like, you know, sort of are biased by whatever, how we measure. But we have to assume there is one real world. And that, again, we end up in this political situation, right? Where we have now the situation that we have 30 years of this post-structuralist theory where people say, oh, you need to see the world through all these different lenses, and now the right wing has adopted that too, but it's like, but wait, like there's still one real world, right? Is there? And so that is sort of like the conundrum where we ended up right now, I think, which is a really, really crazy notion. And the only thing that probably helps is more performance of measurement, visualization, and sort of like dealing with this. And so do you see that is this becoming more liquid? Like, is not only our tools are getting better, but is it there with the tools getting better and more fluid and more liquid? Do you also see that the whole thought process is getting more liquid and the data becomes more liquid and everything becomes more questionable? Or like, is that something you would subscribe to? Or
Yeah. Well, I'll just speak for like my own little research corner of the world. And I will say that, you know, there has been over the last like 5 to 10 years, a lot of this work that's sort of questioning norms. And when I talk to people about this, like there's a lot of interest in better understanding, like how do we think about these things in structured theoretical ways. And people have been, you know, more people, at least in my own community, have been looking outwards at social sciences, at STS, at design communities, and looking at the more theoretical works in those communities and thinking about what it means for us. So at least within visualization, and I'd say also definitely in human-computer interaction and HCI, there's a lot of people out there who I think are embracing and embracing these different ways of knowing. There was a second thing I was going to say. Sorry, my brain is turning off a little bit. But shoot, what was it?
questioning norms?
Yeah, there was something beyond just, yes, I'm definitely seeing a sea change, and I think people are viewing it differently. I mean, I also think that for better or for worse, this sort of like incredibly disruptive and highly advertised thing that's happened with large language models in the last 2 years, I think has also helped bring forward this discussion around the ways in which technology is going wrong, and people trying to understand, like, if technology is, if it's just about the data, then how can it be so like racist? Well, it turns out your data is racist. like I think it's giving space to have these conversations. I think things going wrong as of late are giving space for us to have these kinds of conversations. And I'm finding a lot of interest in it in my own community. Oh, I know the other thing I was going to say. This is also where I think people who do sort of sit more on the engineering side or do a lot of kind of more engineering technology creation work, that is my home. And when I look at what has been going on in like the critical data studies and in these STS communities and things like that, I get quite frustrated sometimes because, you know, I read papers and critiques and you go along and you're like, yeah, totally. Oh yeah, I see that. I see that. And then it just ends. And I'm always left with this like, but what do we do about it? Like if we think about data in this sort of produced entangled way, like, okay, now what? And there isn't a lot of answers from these communities, and that's not necessarily, I think, what their sort of goals or research, you know, sort of ideas are supposed to be about. But for me, as someone who is very much sort of a maker and a builder, my interest is in like, how do those ideas then actually translate into the actionable things that we do when we design and create technologies? And that's where, you know, I'm slowly building up here in Sweden a small network of colleagues who are similarly in that space, you know, people who work in human robot interaction and in AI and things like that, where we're just like, how do we actually take these critical perspectives and change the way that we do engineering work? And that to me is a really, really exciting space and one that I think has not been well trodden yet. So that's where I think, you know, teaching more students and making space in engineering disciplines, data science disciplines, to have these conversations and to, you know, to learn about the word epistemology and learn that there's different ways to think about how knowledge comes to be and that these can all be tools that we can use in our research processes is like a big opportunity for us to sort of change things.
Thank you very much. There's a question by Mark Hannett.
Hello, thank you for a wonderful presentation. I come from art and technology, and also I have a mixed background between design, art, and computer science.
Oh, you're one of those unicorns.
But I had been one of my areas of like expertise and work has been in data visualization. In fact, I saw you presented this wonderful paper in BIS, and we had a paper in BIS art. In the BIS app in the section, like a pictorial, a long paper. But yeah, I had a comment because like, and it was regarding this paper. Actually, I look about this physicalization of like, I need to show to my daughter. She's super fan of Lego, and maybe we do some experiment with this visualizing with Lego. She loves it. But this is like, there is a problem now about this information. When we have a lot of information nowadays, we have a problem with this information. And I think one of the problems is that people in general, like general population, has a lot of hard understanding of figures, like with data, like the visualizations. They don't know how to read it. And they don't know how to read science. They don't know how to read visualizations. Means there is like, we have a hard challenge to kind of like raise the literacy towards like the reading data, I think, because this is one big factor on this disinformation of general population. I think artists, we can do many things too, like with like visualization of data physical, like you were saying. For example, just to put you some example, we had been using metronomes for sonifying data since 2010, like physicalization of data with sound. Things like this, because they kind of like, sometimes the reading data on visual, especially when it gets complex, the data, like people don't get it. And just like they don't know how to disentangle the different layers and the different dimensions of the data. But definitely this is a it's not a one problem solution. I mean, there's not one solution to this problem, I think, because it needs to be maybe taught in the high schools, in the schools, certain ways, maybe at the beginning physical, and then more like how to read figures. I mean, what do you think about this? I mean, I just is a pressing problem. I see that you are kind of interested, I think, for everything you mentioned.
Yeah, I mean, yes to all of that. There's a lot of things in that comment.
Sure, sorry.
Yeah,
But
no,
that's just like,
I don't know. It's really interesting. Like, you know, my first foray into some data physicalization was with a Master's of Design student who was interested in thinking about data physicalization and was really wanting to engage with kids And so we did some interviews with some local school teachers who teach like grades like 4 to 6, so like kids who are like 10 to 12. And this was really eye-opening to me when we asked them about the sort of data literacy curriculum in, you know, sort of the school system here in our commune and in Sweden more generally. And they were just like, the only thing that we teach kids about data at this age is with relationship to social media and how to be safe. And
Yeah.
so, and they were like, you know, it would, they were like so excited about the idea of the sort of potential of bringing in tangible notions of data into their classrooms, and in particular, having data literacy, visualization literacy, as you're talking about, having these things potentially not just be in science and math classes. So like when you get to the higher grades, they were saying like in gymnasium, you know, kids start to learn about data and things, but it's almost always in a sort of science context. And I think that that sort of lens that doesn't help us give people a sort of critical feeling for data, and maybe also a sort of like inclusiveness and agency around it. And so they were also sort of telling us that it would be really interesting and important to think about how to bring data literacy into all subjects, in art, in geography, in language arts, and all these things. And, you know, as data people, you can imagine you can come up with some sort of like data thing in really any topic, right? But that's not currently how it's taught. So, you know, I am definitely not an education expert, even though many of my projects butt up against it. I'm always like, okay, we need to reframe because that's a whole field. like
Sure.
let's not get lost in that literature, like rabbit hole. And in the Viz community, I haven't seen really a ton of stuff. Like there's a few papers around visualization literacy and things like that, but it doesn't really, there hasn't been like a whole like sub area of people working around this. So I definitely see it as a huge opportunity and something, you know, that I'm interested in doing here as part of this museum space we have. But then sort of, you know, sort of to the earlier part of your statement, you know, when we ran these workshops with these teenage girls, and this was like, they were like age like 16 to 19. It really surprised us just how hard it was to teach people like how to do the basic encodings of visualization in a short period of time. And so as we sort of went through our different workshops, we had to continually make the visualizations in some way simpler. And, you know, my student and I have talked a lot about this, and it's just 3 workshops with 12 people. So like, there's not a lot we can deduce, but it was amazing how much effort we put into making the process of going from a data set that they created as a group, which actually like was quite easy for them. We had data cards and we had this big like table that basically ended up being like a heat map, but then like going from that to something interesting was so hard. And I forget this, you know, for me, it's just so natural to think about attributes and mapping those to visual encoding channels, and voila, you have a scatter plot. So that was surprising to us. And that's got me thinking a lot then also about how we teach visualization. And I do think we've gotten to the point where we actually are quite good at understanding the basics of how a like view is constructed. Like this notion of like in the Viz community of like having a sort of systematic way to describe data. You know, I have a representation of, I have a sort of structure of it. It's a graph or it's a table. I have attributes, and those attributes can be quantitative or ordinal or categorical. And depending upon that, I know I have different kinds of visual encodings, whether it's color or shape or position, that I can bring to bear to communicate those attributes. Like this is something that I think we've actually gotten quite good at and is now like kind of standard practice and something we can teach. But when we teach this currently, we also teach it from the perspective of efficiency. Like we, you know, now when we talk about how do you encode data using different kinds of channels, whether it's position or size or color, we often talk about them being ranked, and certain encodings are the specialist and others are harder. And when you think, when you dig into like why, it's all because this stuff is motivated by what is the most efficient way for people to decode a number. And is that actually any more like what many of our visualizations are for? Very efficient decoding of quantitative values? And I think increasingly the answer is no. Like there's a lot of interesting work on the kind of embodied and emotional aspects of viz. Like you start talking about physicalization and you get this like tactile. We're talking a little bit about data as a material that we could shape. So I'm interested. I actually haven't taught a visualization course in many, many years. And I've been sort of like toying with the idea of like, what kind of intro course would I teach today? And I think there's a lot of structure, and I think this is around this basic visualization literacy. There's a lot of structure that that we as a community can offer to help people understand how to read a visualization and how a basic visualization is constructed. But why you choose one sort of encoding over another is something that I think would be very interesting to sort of trouble and to present multiple perspectives of. And, you know, a lot of our sort of guidelines that we have are rooted in people like Bertrand, and also Tufte is like this outsized figure in our community. Don't get me started on Tufte. Like a few years ago, I actually went back and like read his books, and I used to teach his like principles like chart junk and data inc ratio and all this stuff. And then a couple years ago, I went back and actually read his books, and I was like, oh my God, these books are a manifesto. They are just opinions of a man who clearly thought statistics was like the greatest thing ever, and designers were terrible people. And so like this completely like changed, like I started thinking about like all the harm I had done by teaching kids all these like Tufteisms. And I don't think they're all bad, but like I think really going back and looking again at these assumptions that we have and where they come from is important, because maybe those aren't the things that we want to sort of assume as the norm anymore. I kind of went off there from your original question, but
No, I think was very interesting. Yeah, I think sometimes the people forgot that is also a communication device, and if you use always the same method of visualization. I used to teach with a master of data science in Catalonia Open University, and yeah, I come these hard engineers, sometimes people with PhD that after PhD they went to do data science because was hot topic to go into the industry, and then I hold the class of data visualization, and then they were like, oh, this is too designy for me. I mean, I am more like on kind of more hard things on data. But what they didn't understand is that there are actually many problems that they have with data if you don't is very hard to detect also, because like when you have a huge data set and you visualize in any way, you also and these kind of problems of detection, like when you have huge data like bar charts, or you don't use like scatter plots because you cannot represent so much data there, and then they were whenever we put like examples of like more arty or designer visualization, they will just like kind of, you feel it that they were not so because they were coming more from data science and science, they will not respect the visual of it, but in fact were much better than anything that they presented, right? Means and they kind of forgot the notion of communication, that then all this information need to channel to some other person that needs to receive it, and you need to also raise the curiosity of kind of explore the data on it, or kind of explore the visualization even if it's not interactive. And you, yeah, this kind of notion I think is kind of the part that in many more of these people who is not interested in design is kind of missing, I think.
Yeah, cool.
Yeah, I would like to have one last question. I find this super amazing as a discussion, to think about this sort of like, what are the modes, how do we teach it and stuff like that. One of the interesting things is, and let me start with Tufte. Like Tufte is like the sort of archetype of a hierarchical patriarchic figure. He's like an authority, right? And this is constantly quoted and cited as if it was the truth. But if you dive deeply, you figure out that, like, he doesn't have his historical sources together. Like, no, it didn't take 300 years to connect the dots of Galileo. Galileo drew a plot where the dots were connected like 600 years earlier and stuff like that. He just did a new version of it because he had a telescope. And so these kind of things is, I think, really, really important, that the authoritative figures are less authoritative than we think, while at the same time, what we need to understand is like they did a really good job, some of them, Bertrand too, to sort of like do things which were truly novel at the time. And I think that is sort of like something which, Miriah, you have done really a tremendous, you have a whole corpus of groundwork where, like, my friend Ruth West at UNT would say, you didn't take prisoners. You did not go to the bookshelf or to the sort of like grocery store of design principles and like, you stumbled to get a dashboard. You sort of like created new paradigms. Actually, in this manner, I was sort of lucky to teach a course called Using Information Visualization to Think, which it took the dean about 4 years to sort of like convert it to regular data visualization. And my point in this was that we construct data visualizations to understand the data, not to communicate something we already know. And we don't use the methods that, everybody does. And obviously you get 10 students doing this. One of my students went on to the business school across the school, and he did the other thing, which is filling a classroom with 160 students, teaching whatever is in the upper right corner in data visualization in the Gartner quadrant every year. And so that is obviously more lucrative for the university. And I'm afraid that we have less foundational research and less innovation going on in the area, relatively speaking, because everybody learns the same thing. People don't learn to think in pencil and paper. They learn how to do scatter plot with, tidyverse or ggplot. And, if you ask them, like, oh, can you change the axis title? How else could you do that? Like, there's one student present. She will know that, like, I typically ask people more foundational questions, like, how do we do this? And I don't care if you do it in Excel or in R or in Python or whatever, if the principle is correct. So here's my question, like, how did you come up with the courage and the motivation to do these like outrageous things, which are completely out of category within sort of like, the orthodoxy of data visualization, basically?
That is so kind. Your words are filling me with so many warm fuzzies. Thank you. I don't think it. Yeah. I think it's been a series of there's something that this has happened multiple times now in my career where I feel like there's something that feels important to me, and I have people around me who are like, but why is that important and why is that research? And then I have to go off and spend some time trying to like understand for myself, because I don't always have the best confidence, like, well, gosh, maybe that's not research. Maybe doing collaborative design work in visualization is like not really research. Maybe there's no research in that. Or maybe doing collaborative visualization design work shouldn't like be tested and assessed with quantitative user studies. And if not, does that count as research? Gosh, I don't know. It's like these things that I've been confronted with when I'm doing things that feel like they matter to me, that have led me to understand that there's other communities out there who think about things in different ways. And that's the thing that has just exploded my world open. And the most recent round of that has come with working with folks like Lauren Klein and others, and thinking about these feminist perspectives that for me really sort of center power and privilege and how we can use that to rethink like where things come from. That's been another whole sort of awakening for me. And I don't know, I got tenure and so they couldn't fire me, so I could go off and do a sabbatical and learn about qualitative research and design research. Then I moved to Sweden and they gave me a permanent position with a fancy title. And so I was like, well, I guess I can do whatever I want for a couple of years. That's helped. But really, I mean, I think it's really just about like doing things that to me seem really interesting, and then having a lot of critics around me that I felt like I needed to address. And what a unsatisfying answer to your really nice question.
No. This is a very satisfying answer. And I think this is sort of something which, very rarely gets to this point. Like how do we do multidisciplinary research is one of the main things of this whole lecture series. Like, how do we actually perform this? Like, how does a cultural historian like Milo Eber work together with a sociophysicist like Mikhail Tom? And obviously the answer is folding it out, talking to each other. But like what you say, basically, if you come up with a new paradigm, you have to sort of like find your own critics to sort of like keep you sort of like to keep the ship stable. I think that is a really important thing, and very nicely said.
Yeah.
So it's the top of the second hour. So this was an amazing conversation. Thank you very much. I have to announce the next speaker, which I do right now, and I have to change the browser window here because it's a complicated title. So our next speaker will be Alexandra Arkhipova, who's an anthropologist, and so this will be not a fun topic. It will be necro speech, Russian talk and silence in wartime. And you all know why we need to have that conversation. We're in Estonia, and so this is all very important to us. And by platforming this, we think this is something that everybody should know. This is will be the fourth keynote. This is the third keynote. In 2 weeks, we will have Iyad Rahwan from the Center of Interaction of Humans Machines. And so basically, the idea was to span this kind of rainbow of things or aspects, bringing them together in sort of like a crystal of 5 keynotes that will hopefully resonate for the next 2.5 years. And we will announce like how this will proceed. And now at the end, thank you very much, Miriah. This was really super inspiring. Yeah, I hope to see and read a lot of stuff in the future, and I hope maybe we can collaborate. Thank you very much.
Thank you, guys.
Thank you.
Okay, so